in the x to the derivative. Don't keep it general. Keep on making that mistake. Plug in the x. Got it. How about normal? Perpendicular. Perpendicular slope. Opposite reciprocal. -1 over prime of a. 1 over f prime. Right? Opposite reciprocal. Perpendicular. How about there's something is increasing? What do I think of? Derivative? If you're looking at a graph of if you're going to look at where values are positive, if I do it by hand with a I'm going to find what? Critical numbers and make a and look and see where the derivative is. So I'm going to find my critical number or and find where the derivative is. Okay, hold on. This is a tricky one. What if they ask me for where the slope is increasing or yet application problem? The rate increasing. F what? F double. Need to look at the prime of the F double prime. Same drill. Pennies, sign chart where it's positive. Wait, hold on. Is a sign chart ever enough work for explanation? No. Never. You have to put whatever it tells you in, and don't be vague or ambiguous. Right? Don't say it. Tell me what it is. Don't say it. Tell me the slope of what. Okay? How do I find? Oh, hold on. This is poorly. I'm gonna keep going. How do I find critical numbers? 0 or D and E. How do I find? What? Answer. That's not enough. Slope prime 0 or D and E, but I have to look change in signs. It's a graph of a derivative. How do I look to see where double prime is changing signs? Tangent where the slope increase to decrease change. Where the slope change direction or derivative is changing. Careful the wording. F prime is changing, increasing to decreasing. Has to be a change. Has to be a change. Right? What if? What kind of question did they tell you if they were asking you to show or explain that the limit exists? Piecewise. So what do I do with the piecewise if I'm trying to show the limit at a separator? Set them equal to each other, kind of, if they're equal to each other, right? Come from the left, come from the right, and see if they're the same. What's different if it's for continuous? Definition of continuous. Do I still check the limit? Yeah. But I also need to test it with the FSV and make sure they're the same. Take the limit to make sure it agrees with it, right? Let's keep going. Ooh, asymptotes. Degree, but careful. Degree test. Because there's something funny, especially with a square, happen with like it should be, but maybe it's a negative, etc. But also, I'm taking it to where? Infinity, but also have to check this, right? To what? Negative infinity. Check both directions. Sometimes they're the same, it's no deal, but every now and then, negative infinity, make a change. And I think, please say yes. Ooh, yeah. I was last time. There was something like this, like that. And it was part of a bigger problem, but the idea is that I'm taking infinity of, to infinity of e to the x. Is this approaching? Infinity, but it's taking the limit as x to negative infinity once it's part of a bigger problem. But how does it change? It would be 1 over e to the infinity, which would be 0. Keep an eye out for those silly AP guys tricks, okay? First rate of change.
1 over
Slope of it lined or f of b minus f of a, b minus a. Yours, Benji, and in just a second. Instantaneous. Oh, that's easy. How about value of? 1 over b minus a, integral from a to b, f of x d. Let me show you an example. What if you were given v of t, and they wanted you to find average velocity over, I don't know, the 5. I don't want to use acceleration. I don't want to use a derivative. I don't even want to find a slope. What do I want? Average velocity is x or s of b minus s of a all over b minus a, but I don't have s. What do I have? So I need to v and go. Here's an application. Here's an application average value. I want average velocity. I have velocity. I have to do with the integral. Average value of I have. Go ahead. Let's just do a couple more. Let's work. Want to get to. There we go. Candidates. Endpoints. Critical numbers. Not enough just to get the candidates. That's one step. Do with the candidates. Plug into what equation? The original equation. I need to take those points for now. They say relative, whatever. Critical numbers are fine, and plug in the original. Find the largest max, find the lowest for them, etc. Stop here. I think show the p function is differentiable. What is true before something can be? Continuous. Oh, that was a trick. Check first continuous, and then if I have a graph, look at sharp vertical tangent lines, or if I have a function, take derivative if it's piecewise. Find. That's random. That's where next. It like hold on. That's creepy. That's not what I want. There we go. If I have a piece function, you guys have seen it. This is something that we always get stuck with. If I have x is equal to, I don't know, and I'm like 2x for x greater than or equal to 3 and 12 minus 2x, I'm making things up, less than 3. Does that work? Yeah. If I want or not he's differentiable, would it be x equals 3? How would I show check that it's continuous first? And 2 times 3, well, what? 12 minus times 3, right? Does it work? Yes, so it's continuous. And you could show it with really easy, like the limit as x to 3 from above. But what else do you check for differentiable? What would x equal? 2 for this one. But negative 2 for, ooh, is he differentiable? Nope. 3 positive. Look at 3 side. Negative, not differentiable. That's not going to work. Just a little reminder. Let's go ahead. You have that out and ready. This is actually on the website underneath AP. If you want to kind of be quiz, different, this, that, others. There's a lot of good stuff. Speeding up, slowing since we're here anyway. Velocity acceleration have to have that. Same. Let's get out of that. Let's do a few pieces of FRQ. Little baby pieces. Where the actual fun little pieces. There's one. You guys should look at this very long. But if they ask for you to show that F is continuous, this is from an AP grade. She's done a lot of stuff with the AP exam. And she says one student's commonly. When you see continuous, think definition of continuity. So, below, plug in. It's going to be 1 minus 0, 1. Limit from above. Again. But I have if the limit exists, yes, from below and from above. But I also have to say point exists. But that's dumb. That's the same time. But the point exists and the limit equals the point. Just state it. Cool? that you have to fully split. You can use you should use your calculator. Important calculator things for you. How can you answer the question? What am I looking for if I'm to use my calculator? When the particle changes direction, could ask something like, when is it moving right or moving? What do I want? Velocity changes sign. Give me changing direction or changes in direction. So I could look at the graph, and even better, hey, wait, the 0 to 5, can I kind of like cheat just a little bit?
A little bit.
Now, should be able to see it no matter what one because it's 0 to 5, but we could use our window and then say, changing direction, a graph of velocity or position prime, looking at where it changes sign, and it's going to change sign, going from negative to positive to negative, right? How could I find those two? Easy, I'm not going to do it. Go your zeros, right? Question. How can I know whether or not this is increasing or decreasing? 4. Acceleration, velocity. I already have velocity. Yeah. So can't I say, shortcut, trace. If stated, of 4 is equal to less than 0. But what else do I want? You could go trace, you use value, it just takes more time. Or you can just hit the trace button and you come to a place. That's velocity, but acceleration. Ugh. I have to take a derivative? Things are going to make mistakes and things. People are going to make mistakes by doing that. I apologize for calling you things. How do I do a derivative? 4. Derivative is negative 22. Didn't realize or remember. Where else can we take a derivative add up in our calculator to save and not make mistakes? Do it here, but can't also do it. Hold on, tune in. Weeks ago, some of you guys were like, what? Take derivatives? Can't I go take derivatives? Number 8 and 5. Right? DDX. Some of you guys were gone, we did this. There's a little hidden menu. Anyway, and your Y1. Got it. When X equals. Different ways of doing it. Acceleration, negative. Velocity is negative. So I am doing what? Speeding up. Let me show you real quick. Oh, those zeros. Explain. There we go. Velocity is less than 0. Acceleration is less than 0. And shown, don't use your calculator. Speeding up. On over there. Okay, next one. Oh. Kids hated this one. Hold on, we got it. Let me give you a second. What is the when C you need to pull out? That's important. A right initial condition. It's not working. A rate arriving. I say that rate in. I have an initial amount, and then I have what's a tons per hour. Rate what? It's not a related rate.
Oh, all right.
I have a rate in. Gravel's coming in. Is it coming processed or unprocessed? The rate's coming, or gravel's coming in, processed this fast. And then they're doing what to it? Process. So I have a rate in and a rate
out.
In, rate. If I subtract the two, I have the rate of the amount that's there, right? So I have the rate in, I have the rate. And I have subtracting in the rate present. If they were to ask me, don't worry about the gravel, like figure out the math. How can I determine the maximum amount of gravel at the plant? Not coming in, not out, but at the plant. When you see the max. When you see the, what do you think? First derivative, set equal to 0. Critical numbers and endpoints are 0 and 8. Critical numbers of G, of rate in, of other one, call him H, rate out, or of G minus H. What do I want? 0. The rate going out, or the 2 subtracted for my critical numbers? The 2 subtracted. It's not asking for in or, it's asking for at. So I'm going to find the critical number. How? Calculator. Go ahead and graph G. Then graph the rate minus the rate out. Zeros, please, and find it. Then test candidates. Wait, where are those numbers coming from? Integrate net change. I'm into, you guys told me the original, right? But how do I find out at the plant? How much was there to begin with? 100 plus how many in during the, and you have to take how much coming in is how much coming out. Takes the rate and says, hey, I'll find the number of tons. Integration as change.
What does like the maximum is like
When they say the maximum, they're not looking a maximum, but the maximum. Absolute. Cool, let's stop here. You're given a what? Derivative. So, given a graph of the derivative, if I want to find, we might go here, but if I want to find the n, I'm given f prime to find min. Wait, give me something. F prime changes positive to negative. From min? Negative to positive, right? Negative to positive. That is 0 or a d. Anyone see where that's going to be?
There.
6.
1, 2, 3, 4, 5, 6. Yeah. Change F prime. You word it though. Hopefully you can see. Can you word it? At x equals 6 is the only critical point. Say all that, but basically F changes from negative to positive at 0. Local. Have a little more time. How would you find? Don't like this. The absolute min of F. Have F. Test. Endpoints. Oh, and 8. So relative. Yeah, like relative extreme are zeros. Could you 1 and 1, 2, 3 and 6? Can you test 1 and 6? Yes, but which one will automatically say? Psh. Not going to be at the min, and it's also be at 1. Why, guys? The f prime is positive. What's f doing? Increasing. Increasing to 1, and then it keeps on doing what? Increasing. And how much? Well, it increases to what? The under is the change. Oh, so it's going to increase to f is I shouldn't say it. F is going to increase by 2, then it's going to increase 6, so it's going to go up, go down, up 7. Should you be able to figure out where it's the highest? Up 8, down, up 7 is going to be the highest. At 4. Why? Because you could take the initial actually give you to begin with. Give you to begin with. Hold on. What was the initial condition? Oh, F of A is 4. There we go. You can think about this one 2 ways. One way. This is one way. You could talk about how from 0 to 4, there's an increase of 8. From 4 to 8, what's the overall range from 4 to 8? So if it increased 8 to 4 and then 4, well, obviously, which is higher? Yeah, the one that increased 8, so that'd be at. Actually do like a whole little paragraph and explain that you see about the areas. Or you could actually do the math. You know what? I'm testing 0, I'm testing at 4 and I'm testing it. Question, go ahead. Oh, because they gave you the condition. F of 8 is 4, so they're backwards. So at 8, I wish I could write out. At 8, value is 4. So then subtract 7 at 6, my value is -3. Add 3 because they're backwards. They're a mess. They gave you an 8. So you would subtract 7 to figure out where it is at 6. You would add 3 where it is at 4. And you subtract 8 to figure out where it is at 4. And you can test all. I know. They gave you no subtracting. So it happened at 4. Most increase happened 0 and 4. There's the most area. All right, cool kids. Make the bad one. Hold on, pause. Pause. I want to end one last place. I'm not going to do this in the morning. Give you food, and I'm going to comfort you. Be okay, okay? Trying to be fine. So, over. I said, I know the last thing. Find y equals f of x, where f of 5 equals 4.